Okay, so this is a quick tutorial for generating the inverse graphs using reflections in the coordinate plane. We start by looking at this graph. This is a graph of a cubic function. And we have a question here that says, is the inverse graph a function? And this is something we discussed in class. And we should be able to answer this, and we should be able to say the inverse graph will not be a function. And then there's a follow-up that asks, how do you know? And you should be invoking the horizontal line test, because when we draw a horizontal line that intersects a graph more than once, it means that the inverse of this graph will not be a function. So it fails the horizontal line test. And now we're going to go on and we're going to generate the graph of the inverse function using the reflection across the line y equals x. Now, when you're in geometry, you studied transformations. And when you study transformations like reflecting across the x or the y-axis, you learned motion rules. And then you also learned a transformation for reflecting across the line y equal to x. So when you reflect across the line y equal to x, we have this motion rule that says we can do this geometrically, or we can do this by taking points with xy coordinates and switching them to their yx version. And that's basically what we've been doing in class when we talk about generating inverses. We say switch the x value with the y value, or we said we switch the domain with the range. But now we're going to practice this with a cubic function, and we're going to reinforce all of these concepts along the way. So first we draw the line y equals x. We discussed this in class. It's all of the points where x and y values are the same. So here's the point 0, 0, here's the point 1, 1, here's the point 2, 2, here's the point negative 2, negative 2, and they connect and they make this line, and we're going to reflect across it. So now we're going to find some coordinates that we could reflect across this line, and here is a nice coordinate. And I say it's a nice coordinate because its coordinates are 2, 3. And we say, well, those are nice numbers. There's no decimals that we have to worry about. And we would like to reflect across this line. And the thing we have to remember is that when we reflect, we need to be perpendicular and equidistant. So the reflection should end up right here, because that's equal distance from the line and it's following a perpendicular path. And we see that this gives us the coordinates 3, 2. And we say, well, that's what we've been saying that we need to do for inverses. This geometric transformation accomplishes that for us. And you see I have a list of points down here that all have nice coordinates. When I say nice coordinates, that means we have whole number integers for the x and the y values, and it's very easy to just exchange those values. So now you see that this is the first point we reflected, and then as I come down this line, this path, I'm looking for the next point. And we say, great, but now as I go past this, I'm still following this green path. And I say, well, the point I just created is also a point on the line. I'd like to reflect that also. And that means that these 2 points are going to be their own reflections of each other. So I'm going to take this away and say, now I'm at this location and I'm reflecting it back. So both of these points just happen to be reflections of each other, and both will be needed for the inverse graph. But now what we want to identify is this was the first point I reflected, so this point will be first in connecting my inverse graph. As I followed along here, this was the second point I reflected, so that means this is the second point that would be connected from here to here. And again, as I continued up here, this was the third point I reflected, so that means this would be the third point connected in the series, and my graph is going to do this. Let me erase this so we can see that better. So we said that the order would go like this, and that's the shape that the graph is going to take in the inverse, but we would like some more points to just reassure that we're doing this correctly, and I'm going to continue generating points. We see that as I trace further down this green graph, I came to this nice point, negative 1, 0, and when I reflected it, we got 0, negative 1. And that's the end of our nice points here. I see that there's nothing else that's nice on the rest of this green graph. There's going to be some sort of decimal value involved. And that's what we're going to do. So I could make one of my 2 values, either the x or the y, a whole number integer. And that's why I'm going to choose this point here to reflect, because even though the x value is not precise, the y value is. And I'm approximating this to be 2.25. That's this point here that I'm looking at. 2.25 comma 5, so that when I reflect it, I should be at 5 and then about 2.25. So it should come right across the line to this location, and that'll give me another point I can connect when I'm doing my graph of the inverse like this. So let's generate some more points. We've got this 2.25 comma 5 being reflected, and then further down the graph we saw that we've got a I guess it's about negative 1.5 with a negative 3y value that we reflected. And then further down, again, I had at least an integer for my y coordinates, and I just approximated my decimals for my x coordinates. And now I've got a series of points I'm going to be able to connect. That's going to give me a graph that looks like that. So this is just an animation identifying all the points we reflected and the order that we should connect them in. And then you just play connect the dots in that order. And this is your inverse graph. So it's a better representation of it as what I was trying to accomplish. And I hope this helps. This was a more complicated graph to have to reflect and find the inverse of. Some of the other graphs we're doing are quite simple and don't require so much strategy. But again, I hope that this helps.